Section 10.6 talks about Fourier series. The Fourier series of a function f of t is given by f of t is 1 over 2a sub 0 plus a sub 1 times the cosine of 1 times pi over pt plus a sub 2 cosine of 2 pi over pt plus a sub 3, so those match, and this list goes on in terms of a sub n plus b sub 1 times 1 times, and here we're taking the sine of 1 pi divided by pt plus b2 times the sine of 2 pi b3 3 pi t over p. P is the period. So the period, actually the period is 2p. I'm sorry. The period of the function is 2p. So whatever that is, that's half of it. And if I write this, a sub 0 over 2 plus the series n equal 1 to infinity, and I just put an n right there, that will generate all of those and all of those. So, what's the catch? This is fixed. You need to find this, it's right there. And you need to find this, it's right there. And you need to find this, it's right there. So the way it works, I need to find a sub 0. Once I find a sub 0, I throw that in. Once I find a sub 1, I throw that in. And once I find b sub n, I throw that in. And that's pretty much the series. And that's how it works. So those formulas are provided. You don't need to memorize those three. You just have to find them. It's a bit long, but not that hard. Keep in mind, the cosine of n pi is always 0. The sine of n pi is always 0. The cosine of n pi, if n is even, it's a 1. And if n is odd, it's a negative 1. And remember that the cosine of negative n pi is the same as the cosine of n pi because cosine is an even function. So we're going to start with example 1, and let's keep those handy so we kind of see how this works. So anytime we say find the Fourier series, you're going to have to find 1, 2, 3. You know what? Let me color code them. Here we go. Those 3. And once I find those, I substitute those in. And pretty much I'm done. You don't need to write it in summation. You could leave them in expanded form if you wish, and I'll demonstrate. So when I look at the first problem, obviously p is, we're running from negative 2 pi to 2 pi, so p is 2 pi, half of that. A sub 0. So to find a sub 0, you know what, let me stick with the coloring underneath. A sub 0 is 1 over, and if you look at p, well, let's see, we're going to integrate from what? From negative 2 pi to positive 2 pi. Do you notice whatever this is, you just write that down there? Of what? F of t. What's f of t? Well, that is going to be 1 over 2 pi, the integral from negative 2 pi to 0. F of t in that case is a 0, plus 1 over 2t, the integral from 0 to 2 pi. Excuse me. F of t is 2 dt. So this is 0. This is 1 over 2 pi. The integral of 2 dt is simply 2t evaluated from 0 to 2 pi. That is 1 over 2 pi times 4 pi minus 0. That turns out to be, so the pi's cancel, that turns out to be 2. So I got my a sub 0 to be 2. Very good. Now I need to find a sub I want to find a sub 1 first. So before I go to a sub n is really a sub 1 plus a sub 2 plus a sub 3 and so on and so forth, all the way to a sub n. So I want to find a sub 1, and look at the formula for a sub n. All what you have to do is take that n and put a 1 right there. So that would be 1 over 2 pi, the integral from negative 2 pi to 2 pi of f of t times the cosine of 1 pi over p cosine of 1. And the reason I'm putting 1 because we're finding a sub 1. Pi, but we know p is 2 pi t dt. So what would that be? And you notice I'm working straight to the right so you can see the whole thing. That's 1 over 2 pi times the integral, again, from negative 2 pi to 0 of 0 times the cosine of t over 2 dt plus the integral from 0 to 2 pi of 2 times the cosine of t divided by 2 dt. Alright, so this here is gonna be 1 over 2 pi, the integral. This is 0. No need to write that. I'm gonna write it only for your notes. Plus, this right here is what? This is 2 times, what do you take a derivative to get the cosine, the sine of t over 2. And what do you do with that 1/2? If you take a derivative, you multiply, and if you take an antiderivative, you divide. Dividing by 1/2 is multiplying by 2 over 1, evaluated from 0 to 2 pi. So that is 1 over 2 pi times 0 plus 4 times the sine of pi minus the sine of 0. Well, those both are 0, so I get a 0. So it seems I'm getting those to be 0. Now, I need to find the Fourier series. So a sub 2, I could find a sub 2, but most likely that's going to be 0 as well. Let's do that. A sub 2 is 1 over 2 pi times the integral from negative 2 pi from negative 2 pi to 2 pi of f of t times the cosine of 2 pi over 2 pi t dt. So that's going to be 1 over 2 pi, the integral from negative 2 pi to 0. I know the function is 0, and those are going to cancel out. Plus the integral from 0 to 2 pi of 2 times the cosine of t dt. So that's a 0. I am left with, run to the next problem. Again, these problems are lengthy. That is 1 over 2 pi times 0, again, you need to write that, plus twice the sine of t evaluated from 0 to 2 pi. That is 1 over 2 pi into cosine of 2 pi, sine of 2 pi is 0, and sine of pi is 0. I'm getting a 0 again. Now, for the first problem, I'm going to find those three. And I'm adding those two. Again, I didn't anticipate those to be 0, so let's find those as well. Well, what's going to differ? You notice those two integrals are almost the same thing. This is the same limit on the integral, 1 over p f of t, but instead of a cosine, it's a sine. So if I want to find b sub 1, just like I did in the previous problem, I will say b sub 1 is 1 over 2 pi, the integral from negative 2 pi to positive 2 pi. So this is always half of that, of f of t, the sine of, again, 1 pi over 2 pi t dt. And that turns out to be 1 over 2 pi, the integral from negative 2 pi to 0, that's 0, no need to write that, right? Plus the integral from 0 to 2 pi, and f of t in our case here is just a 2, times the sine of t over 2 dt. So the work is almost identical. 1 over 2 pi times, this is a 0, no need to worry about that. This is twice negative the cosine of t over 2 times 2, evaluated from 0 to 2 pi. So b sub 1, I'm getting it to be 1 over 2 pi times negative cosine of pi minus a negative cosine of 1, of 0. That is 1 over 2 pi times, this is a negative 1. So that's a 1, and this is a 1 plus a 1. I'm getting that to be 2, that's 1 over pi. Okay, I got the first b. Let's find the second b, b sub 2. So the work, if you're going to do those individually, they're just showing you how do you get that. b sub 2 is 1 over 2 pi, the integral from negative 2 pi to positive 2 pi of f of t times the sine, and again, of 2 times pi t over 2 pi dt. So remember, the denominator of this right here is the same as that right there. And the top is going to be n times pi. So if n is 1, that's 1 times pi. If n is 2, that's 2 times pi. And you'll notice how this is going to play. This is negative 2 pi to 0 of 0 times, no need to work that out, plus the integral from 0 to 2 pi of 2, which is my function, f of t, times the sine, and those cancel out, just t. And the next one will be 3 halves, and it'll keep on going up. And what is that? That is 1 over 2 pi times twice negative the cosine of t evaluated from 0 to 2 pi. So b sub 2 turns out to be the 2's cancel out, 1 over pi times negative the cosine of 2 pi minus negative the cosine of 0. Well, let's see. That is 1 over pi times a negative 1 plus 1, which is 0. So b sub 2 is 0. b sub 1 exists, b sub 2 is 0. Now, from what I saw, it seems that all the a sub n's are going to be 0. And all the b sub n's, this is 1 over pi, this is 0. Now, if I go for b sub 3, b sub 3 is 1 over 2 pi times the integral from negative 2 pi to 2 pi of f of t times the sine of 3 times pi over 2 pi dt. That's going to be 1 over 2 pi, the integral from negative 2 pi to 0, no need to worry about that, plus the integral from 0 to 2 pi of 2 times the sine of 3/2 dt. And that turns out to be 2 times negative the cosine of 3/2 t. Instead of dividing by 3 over 2, you multiply by 2/3, evaluated from 0 to 2 pi. So that turns out to be twice. If you put the 2 pi in, you will get negative, you know what, I'm going to take that 2, that will make that 4/3. Negative the cosine of, if you multiply this by 2, that 2 cancels out, that's 3 pi minus negative the cosine of 0. That is 4/3, negative a negative 1, plus 1. That turns out to be 8/3 times 2, which is 16/3. So now if I look at my series and how it should be, I should have f of t equaling a sub 0 over 2 plus a sub 1 cosine, and I'm just copying this part, a sub 1 cosine of 1 pi over, the period was 2 pi t, plus a sub 2, the cosine of 2 pi over 2 pi t, plus a sub 3, the cosine of 3 pi over 2 pi t, plus a sub 4, the cosine of 4 pi over 2 pi t, plus b sub 1, the sine of 1 pi over 2 pi t, plus a sub 2, the sine of 2 pi over 2 pi t, plus b sub 3, the sine of 3 pi over 2 pi t, plus b sub 4, the sine of 4 pi over 2 pi t, and that it goes on. If I fill in the blanks, that is a sub 0, I got that to be a 2 right there. So that would be a 2 divided by 2. Again, this is a sub 0. Plus, do you notice that we got a sub 1 to be 0 and a sub 2 to be 0? And if I find a sub 3 to be 0, which means that 0 times the cosine of t over 2, plus 0 times the cosine of t, plus 0 times the cosine of 3/2 t. Well, aren't all of these zeros? Plus b sub 1. We got b sub 1 to be 1 over pi, plus 1 over pi, the sine, those cancel out, of t over 2, plus b sub 2 turns out to be 0, times the sine of t, plus b sub 3. We got b sub 3 to be 16 over 3. Oh, I lost track. I forgot to multiply that by, oh boy. Okay, there it was. It was all of this mess multiplied by 1 over 2 pi, right? So all of this times 1 over 2 pi. That turns out to be 8 over 3 pi, because 2 divides 16 8 times. My mistake. Plus 8 divided by 3 pi times the sine of 3/2 t, right? And that's where we stopped. So if I list a few of those, I'll notice that f of t is actually 1. The cosines are all going to cancel out. Plus 1 over pi the sine of t over 2 plus 8 over 3 pi the sine of 3 halves t plus the list goes on. So this is good enough. What they do in the book, they factor out the 1 over 2 pi. And they say that is the sine of t over 2 plus, if you take the pi out, that is 8 over 3 the sine of 3t over 2, and the list goes on. And that would be the Fourier series for this function f of t. Now, the idea of U listing, we want to find the periodic. We really want to find a sub 0, a sub 1, a sub 2, b sub 1, b sub 2. We should find a bit more to figure out the pattern. But here they just want the first 3 or 4 terms. So they're specific on the homework. Now if they just say find the actual power series, like here we're finding b sub 0, b sub 1, and b sub 2 first, then find the Fourier series. The Fourier series is you finding a sub n and b sub n. So you could go straight for that. You could go for a sub n first, b sub n first, and from those you could read a sub 0, a sub 1, b sub 0, b sub 1, there is no b sub 0, b sub 1, b sub 2, and go from there. The next video I'm going to do another problem, and it's right there.